Okay, so I am going to do number 1 on page 46. And so in that problem, we are told that we are looking at the, oh God, why is this doing this to me? It did this to me before. Okay, let's try this again. Hold on. Okay, so in the economy of Bermuda, we are told that we produce two things. And if you remember from class, I told you that when you do a problem like this, we should organize the information we have, like so. Let's consider what we produce. Let's consider how much we produce. And with how many factors of production. So in this problem, they tell us that we produce two things. Our fishermen catch fish, and they catch them in metric tons. And the people who work in the hotel industry produce hotel stays. And these are the two things that our economy produces. How much we produce, they tell us that the 306 registered fishermen in Bermuda caught 387 metric tons of marine fish. And that the 2,719 people employed in the hotels produced 554,400 hotel stays. So with how many factors of production? Well, we had 306 fishermen, and we had 2,719 people employed in the hotel industry. Remember, our factors of production are just the things that we're using to produce. In this case, the things we're using to produce are human beings, the fishermen and the hotel workers. This problem tries to get you to a point where you are going to graph a production possibilities frontier or production possibility curve. And if you remember from class, a production possibility curve is a model that shows trade-offs that we need to make in an economy between two goods. So let me plot my two goods here. Let's say we have hotel stays here. Let's say we have fish over here. And it doesn't matter which one I place on what axis, at least for this example. And let's imagine that the production possibilities frontier looks something like this. And so I'm just going to give you a general review of where we're trying to go. I don't know if this is the production possibility frontier for this problem. But the production possibility frontier looks like a line or a curve linking the two axes. And everywhere on this line, we have all the combinations of fish and hotel stays that our economy is able to produce at maximum. Okay, so for instance, if I have a point here, this tells me that with the factors of production that I have, one combination of fish and hotel stays that I can produce is this value over here on the y for fish, and this value over here on the x for hotel stays. This line represents the maximum. Anything over here, so let me use a different color for this. Anything, let's say we have a production point over here with this many fish and this many hotel stays, is not feasible. It's not feasible. It's not possible. This is our max of what we can produce, and anything out here is not feasible for us to produce. Inside the triangle here, so let's say we have a production point here of this many hotel stays and this many fish. This is feasible. We can produce it, but it's not efficient. And the reason why is because from this point, I can produce more of either good without losing any of the other good. So for instance, from here, I could catch more metric tons of fish without having to sacrifice any hotel stays. Similarly, I could produce more hotel stays without having to sacrifice the catching of any metric tons of fish. Anywhere on this line, I cannot produce more fish or more hotel stays without losing some of the other good. So for instance, let's think about this production point here. From this production point on the line, let's consider the case that I want more hotel stays. Well, this line represents all the possibilities of what I can have, the max. If I want more hotel stays, I have to give up some fish to get back on the line. If I want from here, if I want more fish, I have to give up some hotel stays to get back on the line. Everywhere on this line, we say our production points are efficient. We cannot get more of one good without giving up some of the other. So that's where this problem is going to try and get us to go. The problem also gives us one more thing that we should note on the side here, and it gives us the opportunity cost. And remember that the opportunity cost is just how much of one good you have to give up to get another. And in this case, in this problem, they tell us to assume that the cost of one additional metric ton of fish, and I'm just going to write fish, is 2,000 hotel stays. What does this say? This says that that in order to get one more metric ton of fish in our economy, we have to give up 2,000 hotel stays. Similarly, in order to gain 2,000 hotel stays, we have to give up 1 metric ton of fish in production. So the problem is going to try and get you to the point where you graph the production possibilities frontier for this problem. And I'm just going to erase this real quick so that I can start over with the actual points that this problem leads you to produce. I gotta find a faster way to do this erasing. This is my first time using this, so I'll get better with it. Okay, so let's start again. So the problem is going to try to get us to the point where we are again, and let's say this is hotel stays, and again, it does not matter what is on what axis, and fish. So in order to plot this production possibilities frontier, we're going to start with the points on either one of these axes. So a point here and a point here. And what do those points represent? Those points represent, like, so for instance, if we had a point right here, this would be the point where all of the hotel workers had become fishermen and were producing metric tons of fish. So that this is the value of how much fish they caught if everybody is just a fisherman. If we had a point over here on the x-axis, this would tell us if no one was a fisherman and everybody was working in the hotel industry, how many hotel stays we would be able to produce. So the problem is asking you to walk through those steps. So let's take a look at part A. Part A says if all 306 registered fishermen were to be employed by hotels, in addition to the people who are already there, how many hotel stays could Bermuda produce? We're going to ask two questions. One, we're going to ask, what do we lose? What do we lose when all of the fishermen become hotel workers? Well, those fishermen had caught 387 metric tons of fish. So that's what we'll lose, 387 metric tons of fish. What do we gain? This is when the opportunity cost comes in. Because the opportunity cost tells us exactly how much we gain for each loss. Here we've lost 387 metric tons of fish. And the opportunity cost tells us for each metric ton of fish that we lose, we gain 2,000 hotel stays. So what I'm going to do is multiply 387 metric tons of fish times 2,000 hotel stays that we gain for each loss in a metric ton of fish. And if I do that out, it's 774,000 hotel stays that we've gained. Now, it's not over because we had hotel workers already working who had produced 554,400 hotel stays before. So, in total, we have 1,328,400 hotel stays in that economy, if all the fishermen become hotel workers. So that's our point right here. And again, I'm not sure how the solutions on Chegg do it. They might put the hotel stays on the y-axis so that you would have this point up here, and that would also be totally appropriate. So let's look now at part B. Part B, again, it says if all 2,719 hotel employees were to become fishermen, so all these people move over here, how many metric tons of fish could Bermuda produce? We do the same thing. What do we lose? What do we lose if all the hotel workers become fishermen? Well, we lose what they produced, and what they produced is 554,400 hotel stays. What do we gain? Again, this is where the opportunity cost comes in. The opportunity cost tells us exactly this. For what we lose, what do we gain? Well, the opportunity cost tells us for each loss of 2,000 hotel stays, we gain 1 metric ton of fish caught. So I'm going to take 554,400 hotel stays, I'll put that here, and divide by 2,000, because for each one of these hotel stays, for each one of the 2,000 lost, we get 1 metric ton of fish caught. Just put that in the calculator real quick. And we have 277.2 metric tons of fish. I'll just put fish. Again, we had fishermen before that were catching stuff, and they had themselves caught 387 metric tons of fish. So together, that means that if all of the hotel workers become fishermen, we're going to catch a total of 664.2 metric tons of fish. Now, change the color. This here, 1,328,400 goes here, and this 664.2 goes somewhere like here. Probably actually a lot lower. And our production possibilities frontier is either a line or a curve. So here we have to pay attention to what the problem says. It says the opportunity cost in this problem is constant. That's the last sentence of the first part of this problem. That means, and that tells me, that no matter what production point I'm at, I'm going to have to move to the right and down to get on the line in the same amounts over the entire thing. When the opportunity cost is constant, then your production possibility frontier is just a line. Just imagine that that's a line, terrible line. So it's just a line, and this is my production possibility frontier. The last thing it says is to label Bermuda's actual production point for the year 2009. Well, so the production point was somewhere 554, for hotel stays is 554,400. So we'll say if this is 1.3 million, maybe 554,400 is somewhere about here. And it says it's, remember, this was efficient in production, so I know it has to be on this line because this is the line that represents efficiency in production. All of these points of production, all these combinations of fish and hotel stays are efficient. And so this is where my line is. And this is, we can imagine this would be about 387 metric tons of fish caught. Again, I don't know what the solutions do, but they might flip the axes and put hotel stays here, in which case the production possibilities frontier would just look, it would start off higher and then come down shorter onto the x-axis, which is totally fine. You could do it either way. I hope that makes sense. And you can email me if it doesn't.